minute can open your eyes. One book can open your world. Knowledge gives you power. Read and rise higher. 9R Tree. Better life begins in a book.
Hello, I'm Sebastian. Welcome to 9R Tree's podcast. Today, I will summarize and review the book, Designing Machine Learning Systems, an Iterative Process for Production-Ready Applications, by Chip Huyen, is a practical field guide for moving models from notebooks to reliable products. Blending software engineering, data engineering, and product thinking, the book lays out a repeatable loop of scoping, data collection, training, deployment, and monitoring, with an emphasis on feedback that strengthens each cycle. Drawing on industry case studies and hands-on patterns, it explains how to define success metrics, choose the right data, and design for latency, scale, and cost from day one. Instead of centering on algorithmic novelty, the author focuses on systems that withstand change, such as distribution shifts, data quality surprises, and evolving user needs. Readers learn to integrate labeling pipelines, feature stores, testing, and observability into a cohesive platform. The result is a clear blueprint for building ML applications that are maintainable, measurable, and aligned with business outcomes. I will give you key takeaways from this book. Firstly, Iterative ML loop and product alignment. The book puts iteration at the core of modern ML practice. You start by clearly framing the problem, defining who benefits, and selecting success metrics that balance user value with business impact. Rather than chasing state-of-the-art scores, Chip Huyen urges teams to build a minimal viable model that is easy to ship and easy to learn from. The loop proceeds through data acquisition, labeling, training, offline evaluation, limited exposure in shadow or canary modes, and measurement in production. Each cycle incorporates feedback to refine both the model and the product. Practical guidance covers setting North Star and guardrail metrics, choosing baselines that reveal lift, and avoiding proxy metrics that move in the wrong direction. The book also addresses experiment design, including when to use A/B tests, how to size tests, and how to handle seasonality. Cross-functional alignment is emphasized throughout, ensuring that engineers, data scientists, and product stakeholders move in lockstep and make trade-offs explicit on latency, accuracy, privacy, and cost. Secondly, data quality, labeling, and dataset management. Production ML lives or dies by data quality. The book provides concrete tactics for curating representative datasets, preventing leakage, and capturing metadata that enables reproducibility. You learn to build data contracts with upstream owners, implement schema validation, and detect anomalies before they hit training or serving. For labeling, the author covers strategies ranging from high-precision experts to scalable crowdsourcing, with strong emphasis on clear guidelines, calibration tasks, and inter-rater agreement. Programmatic approaches like weak supervision, heuristic rules, and distant supervision are introduced to bootstrap labels when budgets are tight. Active learning and human-in-the-loop review help prioritize ambiguous or high-value samples. The book teaches how to construct splits that reflect production distributions, create gold sets for regression testing, and version datasets alongside models. Practical sampling guidance helps uncover long-tail errors and harmful biases. Throughout, privacy, compliance, and governance are treated as first-class concerns, with patterns for data minimization and audit-friendly lineage. Thirdly, features, training serving parity, and real-time pipelines. A central challenge in production ML is keeping features consistent between training and serving. The book explains patterns for achieving parity through shared feature definitions, feature stores, and robust transformation libraries. You will learn how to design batch and streaming pipelines, manage feature freshness, and prevent leakage with time-aware joins and windowing. The author discusses trade-offs between pre-computed features, on-demand computation, and caching, and shows how to set latency budgets that guide these choices. Practical advice covers normalization, categorical encoding, text and image embeddings, and strategies for handling missing or delayed data. To mitigate training serving skew, The book recommends enforcing the same code paths, using data validation at pipeline boundaries, and building time travel capabilities to reproduce exact training contexts. It also highlights operational concerns such as backfills, drift in upstream sources, and cost control on storage and compute. By the end, readers understand how to design feature pipelines that are reliable, observable, and aligned with the needs of low-latency inference. Fourthly, deployment, inference, and reliability at scale. Turning models into services requires careful systems design. The book surveys deployment topologies such as batch scoring, offline workflows, online request response services, and streaming inference. You learn how to containerize models, select serving frameworks, and tune for latency, throughput, and tail performance. Techniques like autoscaling, request batching, vectorization, and caching are explained alongside hardware choices across CPUs, GPUs, and specialized accelerators. The author gives actionable playbooks for safe rollout: shadow traffic to validate behavior, canary releases to limit blast radius, and blue-green deployments for instant rollback. You will see how to size capacity using P95 and P99 targets, set SLOs, and measure cost per prediction. The book also covers model versioning, routing, and ensemble strategies, plus compatibility with upstream services and feature stores. Testing is treated as a must-have, with unit tests for transforms, offline to online consistency checks, load tests, and golden datasets for regression detection. The result is a holistic view of reliable inference in real-world environments. Lastly, monitoring, evaluation in the wild, and ML ops. After deployment, the real work begins. The book details a comprehensive monitoring stack that tracks input data quality, feature distributions, prediction health, and business outcomes. You learn techniques to detect data drift and concept drift, monitor slices for fairness and safety, and evaluate calibration and uncertainty. The author explains how to set alerts tied to SLOs, avoid alert fatigue, and run post-incident reviews that lead to structural fixes. Evaluation moves beyond static test sets to continuous validation with interleaved experiments, delayed ground truth, and counterfactual analysis when labels arrive late. The ML ops layer ties everything together with model registries, lineage tracking, reproducible builds, and CI/CD tailored for data and models. Infrastructure as code, dependency pinning, and environment snapshots reduce surprises. The book also addresses governance, privacy, and ethical risk management, emphasizing documentation, audit trails, and human oversight. With these practices, teams can sustain model quality over time, respond quickly to change, and turn ML into a dependable capability. In conclusion, designing machine learning systems is ideal for ML engineers, data scientists, software and data engineers, product managers, and tech leads who need to ship dependable ML in real products. It benefits startups building the first ML feature as much as mature teams scaling platforms across many use cases. The book stands out because it unites product thinking with solid engineering and pragmatic operations, reducing time to value while lowering risk. Instead of focusing on one framework or a narrow algorithmic niche, it offers patterns that generalize across domains and stacks. You will gain a step-by-step blueprint for iteration, data quality, feature pipelines, deployment, and monitoring that you can apply immediately. Choose this book over others if you want battle-tested checklists, decision frameworks, and trade-off analyses rooted in industry practice. It will help you avoid costly pitfalls, build systems that are measurable and maintainable, and create ML features that truly move business metrics. If you would like to support Chip Huyen, you can buy the book through the Amazon link I've provided in the podcast description. After reading the book, please let me know what you think and share your thoughts. See you around.
1 minute can open your eyes. 1 book can open your world. Knowledge gives you power, read and rise higher. 9 or tree, better life.